In our notes, mixed and entire radicals. A radical is any square root, cube root, etc. An entire radical is a radical with a number inside. So for example, the number we wrote before was the square root of 18. This would be called an entire radical. When you have a number out front, I guess I could write square root of 18 nicely where it says example. Okay, other ones, square root of 50. How about the square root of 24? There's 3 examples. Those are all entire radicals because the number is entirely inside the radical. A mixed radical is a radical with a number outside of the radical and inside of the radical. So what I'm going to do is I'm going to tell you that the square root of 18, if you type it into your calculator, push enter, find out what it is as a decimal. It's going to be 4 point something. And then do 3 times the square root of 2, and you get the same answer. Square root of 50 happens to be the same as 5 times the square root of 2. And the square root of 24 happens to be the same as 2 times the square root of 6. The mathematical question is, how do we do that? How do we change the square root of 24 to 2 root 6? How do we change the square root of 50 to 5 root 2? How do we change the square root of 18 to 3 root 2? And that process is called simplifying. So to simplify a radical means to reduce it from an entire radical to a mixed radical. And the idea is, can you find a perfect square with square roots, or a perfect cube with cube roots, or a perfect power of 4 if you have 4th roots, and so on, that multiplies. So if we look at the last numbers, can I rewrite 18 here? I'll do this in green as a new step. Can I rewrite 18 as a product of 2 numbers? Yeah, it's 18 times 1, 9 times 2, 6 times 3. But I want to choose one where one of those numbers is a perfect square that you could take the square root of. So again, just like in the factoring unit, our mental math skills and our times table really gets put on display, because we see 18 and you have to think of all the things that multiply by 18 and then pick one that has a perfect square. So you have to also know your perfect squares really well. 18 is 9 times 2. And the square root of 9 is 3. So the step in between here is what we noticed in our worksheet, that square root of 9 times 2 is the same as the square root of 9 times the square root of 2, and the square root of 9 is 3. So it just becomes 3 square root of 2. So you look at 50. 50 is 5 times 10, 25 times 2. Any other ones? 1 times 50. Do any of those have a perfect square? 25 times 2. And so we could have the square root of 25 times the square root of 2, and the square root of 25 is 5. Square root of 24. That's 12 times 2, 8 times 3, 6 times 4, 24 times 1. Do any of those have a perfect square? 4 times 6. And the square root of 4 times the square root of 6, the square root of 4 is 2. Now I'm going to give you one. Ooh. What would be a good one to use? 72. I'm going to start it up here. That is a beautiful looking 7. Square root of 72. 72 is what times what with a perfect square? 9 times 8. Perfect. And square root of 9 is 3. So you did this, and I would say to you, great, but you don't get full marks for simplifying. Why don't we get full marks for simplifying the square root of 72 to be 3 square root of 8? You can simplify square root of 8 further. What times what is 8? 4 times 2. And what's the square root of 4? 2. So do I write 32 out in front now? No. What is happening in between each of these? We don't have to show it, but there's multiplication in between each of those. Just like there's multiplication here, here. And so if the square root of 4 is 2, then we'll have 3 times 2 times root 2. What's another way of writing that? 6 root 2. And this would get you full marks. Which means another way we could have done this. And I'll do it in green. What times what is also 72? 36 times 2. And the square root of 36 is 6. So we're going to find that sometimes we find a perfect square, but it's not the biggest one. It's not wrong, so what we did in blue here isn't wrong, but it just took us longer because when we got to square root of 8, we weren't done yet. So whenever you get your last number, you have to do the mental math and see all the things that multiply to 8 and check, are any of them perfect squares? With 8, yes, it works. It's 4 times 2. If you find the biggest perfect square first, your life is easier. That's why I chose 72, because 72 in your times table, you think 9 times 8 a lot quicker than you think 36 times 2, because you don't have your 36 times table well memorized. Maybe you know it up to 2. 36 times 1, got it. 36 times 2, not so bad. 36 times 3, no, sorry, I'm done. Probably not that bad, but probably not something that you've memorized, that whenever you see 108, you're like, oh, there it is again, 36 times 3, right? And so we have that when we want to simplify our method is we want to find that perfect square or perfect cube that divides the number inside the radical. Here's a starting list of perfect squares and perfect cubes. This is 1 squared, 2 squared, 3 squared, and so on. It goes up to 13 squared. You have to know your perfect squares, mental math-wise, higher than you have to know your perfect cubes, just because the math is harder once you get to perfect cubes. Estimate. Okay? Estimate means don't take out your calculator and type it in and get the exact answer. Estimate says use your mental math skills and tell me what's probably a close answer. Okay? If I look at that, should I say 8,000? No, that would be a bad estimate. Okay? It's still an estimate. It's just a really bad one. Okay? I mean, everything, when you estimate something, your accuracy gets better the closer you are. What would be close to that? 8.9. And how did you come up with 8.9? So I'm going to say, we're going to approximately go 8.9. Why didn't you say 9? Because we know that the square root of 81 is equal to 9. And it's below 81. Why didn't you say 8.1? Okay, so square root of 64 is 8. And it seems to be closer to 81 than it is to 64. So 8.9 seems like a better estimate than 8.1. Has anyone typed it in their calculator yet? What is it exactly? Do you have it exactly? Dot, dot, dot. Nice. So 8.9 is an excellent estimate. But the key thing here is what Regan used is he used some points that he knew. He knew the square root of 81 was 9. He knew the square root of 64 was 8. And since 79 was a lot closer to 81, he went with that as an estimate. Question for you. If you know, if you know the square root of 36 is 6, and you know the square root of 25 is 5, what's the number halfway between 25 and 36? $30 is closer to 25 than it is to 30. 31 is closer to 36 than it is to 30.5 is the number right in between. So a good estimate would be 5.5, right? Because it's halfway in between. My question is, does it work out perfectly? Is 5.5 times 5.5 30.5? No, it's 30.25. Interesting. Because your gut might have said, well, if it's perfectly in the middle, shouldn't it be perfectly in the middle? But no, not quite. So that's interesting. Interesting if you like numbers. Sorry, I find that interesting. Fascinating. But it does work that 5.5 is a good estimate. These ones are asking us to simplify. So we have to remember, oh my goodness, welcome to the complicated definition of simplify. It sounds like it should be simple, because it has like simplify, but the word simplify in math, I think, is one of the most complex words there is, because you have to know its definition, and it has about maybe 30 different definitions depending on what you're doing. Right? Simplify for radicals. And we had this before, means that we need to write as a mixed radical. If you think about it, you have had the word simplify in math a lot already. You had simplify for fractions. If something said simplify 3 over 6, what would you write? 1 over 2. What does simplify in fractions mean? Write in lowest terms. You had simplify in algebra. If you had simplify 2x plus 3x plus 5, what's the answer? 5x plus 5. What did you have to do with simplifying with algebra? You had to combine like terms. Those are just 3 definitions of simplify. There's simplifying with regular math. 2 times 3, simplify. 6, right? It seems obvious that you would know what to do, but simplifying has all these different definitions in math, and you have to know them all. And this is a new one. You have a radical, and it says simplify. That means write as a mixed radical. The first one is a square root. So we see 63. We have to think, what times what is 63? Is there anything where one of the numbers is a perfect square? 9 times 7. So the one thing, like I said before, the one thing that this unit and the last unit really points out is if you thought you just needed to know your times table a little bit, no, we need to know it really, really well. Because if you get stuck on a number and you can't think of the multiplication, that's just one little step in these questions that are coming up. So practice your times table. Practice numbers like 63, thinking, oh, I know that that's 9 times 7, 21 times 3, 1 times 63. How quickly can I think of them all? Here we have a perfect cube. So we have to think, what times what is 108? And we want one of them to be one of our perfect cubes. So how quickly can you think of your perfect cubes in your head? We got 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. Okay? With 64, can you see that 64 times 2 is already bigger than 108? So with your perfect cubes, you only really have 2 that you have to check. Can you do 27 times something to get 108? (27 times 4? And we have to be careful here because with cube roots, you have to write the little 3 each time to show that it's a cube root. And the cube root of 27 is 3. And you're going to be tempted by this cube root of 4 because you know the square root of 4. But you can't do anything with the cube root of 4. 128. We now look at powers of 4. So we have to think of our perfect powers of 4. What is 1 to the 4? 1. 2 to the 4. 2 times 2 times 2 times 2. 16. Okay? So we have to check if we can break up 128 into perfect 4s. 3 to the 4 is 81. 3 times 3 times 3 times 3. One of the things that I like to do with checking out perfect, like powers of 4, okay? Most students will do this. 3 times 3 is 9, times 3 is 27, times 3 is, long pause, oh my goodness, 27 times 3, long pause, 81, okay? Why do you make it so hard? What if I put brackets there? What's 3 times 3? 9. And both of those will be 9. What's 9 times 9? 81. No big pause, right? Very nice. So we've got to figure out what breaks down 128. 128 is 16 times by 8. Have to write the little 4, so this becomes 2 4th root of 8. That's where we're going to stop. You can use prime factorization as well to help you through this. So we'll look at that a little bit tomorrow.